Okay, so shall we start? Everyone ready?
Yes, sir.
Okay, great.
Yes, sir.
So, so we'll follow the same method that in between I'll be asking certain questions. So please use chat box to write your answer so that the class is interactive and slowly we'll build up the concept of 5G new radio, starting from very simple aspect, going into detail today itself. So today we have session 1.5 hour session right now, and then we will have sessions in the second half, 3 p.m. onwards. In between 2 to 3, also we have session from IIT Delhi on 5G testbed. So let us start our topic. Okay, so the topic is 5G new radio, and we'll be covering all the spectrum related aspects. So basically, it's a continuation of all the spectrum related aspects which our Japal Sahab took. So in this topic, I'll be covering. May I request to kindly keep yourself mute. Atul, can you mute the person coming? Noise is coming. So I'll be covering what are the frequency bands which is supported by 5G new radio. That aspect I'll try and cover. Then I will be covering what are the channel bandwidth supported by 5G new radio, and then I will be covering uh, what kind of waveform or modulation used in 5G new radio. We will talk about 5G numerology, subcarrier spacing, resource block, etc. And then we'll be talking about what is the relation between numerology, supported bandwidth, frequency band, cell size, latency, and its uses. And then we will little bit talk about carrier aggregation concepts and use cases, and something more on bandwidth part. So we'll try to cover 8, 6, 7 topics in 1.5 hours from now. Okay, so let us start with frequency bands supported by 5G new radio. So, uh, so you must be knowing that when we say low band, we mean that all the frequency bands which are less than 1 gigahertz, we call it low band. So, do you recall 2G, which spectrum we had been using? Can somebody tell me in the chat box that for 2G in our country, what spectrum we had been using? Earlier, we also had CDMA systems. So, can somebody recall that what are the spectrum we were using? Yes, so I got a few answers. So 800 megahertz, 900 megahertz, 850 megahertz. So these all frequencies were less than 1 gigahertz. That means 2G was using lower side of frequency band. So now my next question to all of you is that uh, what kind of band was used by 3G? Can you guess? What kind of band 3G was using? Yes, so 3G was also using the lower band, and of course, was also using 1 gigahertz. But if you just talk about lower band, even 3G was supporting lower side of the band. For example, if you look at Geo implementation of 4G, they have acquired uh, uh, the CDMA spectrum, which was of earlier company of Reliance Infocom, and they are using it for 4G. So what I'm trying to say that lower band is being used by 2G, 3G, and also 4G. And good point is that these bands are also supported in 5G. And can you guess that when we use lower side of the band for 5G, what kind of application or advantage we will be getting? In the chat box, you can write that in case we are using lower side of the band for 5G, what kind of use cases it will be used for, and what are the advantages? Yes, so your answers are correct. So people have answered that large coverage, yes, lower the frequency, we have larger coverage. So it will give us a large coverage. And because we have a large coverage, we can cover deep area. And the use cases would be for IoT, sensors, actuators network, which will be installed in a deep forest or hilly area or maybe in the basement. So for the lower band, whatever frequency band we'll be using in 5G will be used for these use cases. My next question is that since in India and other countries, these lower band of the frequency are already used by 2G, 3G, and 4G, then how can I use it for 5G? Any guess? Okay, so by the way, by chance, if you recall the auction, what our earlier speaker was talking about, that in 5G, last auction, 700 megahertz band was also auctioned, and this was kind of by Reliance Jio. So they have taken megahertz, 20 megahertz of bandwidth from 700 megahertz. So Jio is having lower side of band, and they are actually deploying whatever 5G deployment you are seeing. It is the 700 megahertz band also. So Jio is using. In case of Airtel, the other operator in our country, they didn't took 700 megahertz band, any bandwidth from the 700 megahertz band. Perhaps they are already having 900 megahertz band, which they have kind of a refarmed from their 2G era, and they also took some more 900 megahertz band in the auction. So they would be using 900 megahertz for these use cases of 5G. Now let us talk about the lower part of the mid band. So the frequencies which are more than 1 gigahertz and up to say 2.6 gigahertz, low mid band. And if you recall, which technologies are working on these bands? Can you guess? Which are the different technologies which is working on 1 to 2.6 gigahertz? Any answer? So yes, 3G operates. So you may be knowing that somebody also answered that 3G was deployed on 2100 gigahertz band, 2100 megahertz band, and also somewhere 1800, 1900 megahertz, right? So 3G is using this particular band, and also 4G. If you recall, in India we are using 1800, 1900, 2100, 2300, and 2500 megahertz band for 4G. So this particular band, whatever allocation was there from DOT, is already used by 3G and 4G. So, but 5G also supports.
Sir, your voice is breaking, sir. Your voice is breaking.
So, can somebody else also confirm whether my voice is okay?
Breaking, sir.
Breaking, sir.
Breaking, sir.
Clipping, sir. Clipping.
Someone breaking, sir.
Okay, let me see my broadband.
But I am able to hear sir properly, basically.
Okay.
Maybe.
Okay. Is it okay now?
Yeah, better.
Yes, sir.
Yes, sir. Yeah, better, sir. Better.
Okay, good. Okay. So the lower mid band all the frequency which are there in 2100 megahertz band, 200 megahertz band, and 2500 megahertz. So 5G support these bands. The only problem is you have
Not audible, sir.
Same issue, sir.
5G.
Not,
So
not
that is
audible.
Voice
Not
is not
audible.
clear.
No,
Not coming clear, sir.
not coming clear.
Sir, audio not audible.
okay. Okay, let me see. So let me switch off my video so that that you can zoom less.
Yes.
Just a moment. I'll just switch off my video. Okay. Fine. Now somebody confirm whether you can see my, you can hear me clearly.
Yes, sir. It's clear.
It's now clear?
Yes.
It's clear.
Yes,
Okay,
sir. Yes.
good. Okay. So once you refarm these frequency bands or vacate from 3G and 4G, you can use it for 5G. Now, mid-band, if you look at 3GPP specification, so they have defined frequencies up to 7.125 gigahertz. So 3.5 gigahertz to 7.125 gigahertz. These are also part of mid-band, but the good part is that these frequency bands are not used by 2G, 3G, 4G, and 5G almost across the globe. So these were sort of free, and these can be actually used by 4G and also by 5G. So across the globe, this is the band in this range. It is being initially used by 5G. So this is some sort of important band which is actually being used as of now for rolling out 5G. In India also, frequency band 3.5 gigahertz band which we offer. So this is the kind of a band which is used by almost, that's why the entire ecosystem of 5G has actually developed around this 3.5 gig. Many of you might be having a handset which is 5G, 5G enabled handset. If you go and check into your phone, this 3.5 gigahertz or N78 is definitely supported. So ecosystem has actually developed on device side and BTS side where equipments are getting manufactured. So this was some sort of new band. And then high band. So this was for the first time that ITU had identified higher side of the band, millimeter band, wave band, and 3GPP has also considered after that. And these bands are, as of now, from 24 gigahertz to 52 gigahertz, identified by and earmarked by 3GPP, and it is primarily for 5G as of now. Although these frequency bands are not specific to a technology, but as of now, since 5G is the only technology which is using these bands, and we call it millimeter wave, all because the wavelength of these frequencies will be in millimeters. So these are the concepts. Let's move. So before we go further,
Sir, 1 minute, sir. Back one slide back, sir, please.
You ask your question.
Actually, in the low mid band, 1.8 gigahertz is being used for 2G also.
That I know that 2G uses 1800 megahertz band also in some cases.
Yes, sir.
Yes, you are
Yes,
right.
sir.
Okay, so let us now talk about ITU, how frequency bands are identified So yesterday also, day before yesterday also, we had talked about. So basically, the ITU, particularly the radio communication sector of ITU, can you mute your mic, please? Thank you. ITU identifies frequency bands for IMT. So mobile communication is called International Mobile Telecommunication, IMT, by ITU. So the countries, specific countries, when they consider, they fall at earmarked or identified for IMT by ITU. Generally, country, origin country, uh, they it's very important to use the harmonized frequency band so that interoperability across the operators across different countries are possible. And it is also important to use ITU so that ecosystem around those bands develop, whole ecosystem of manufacturers, OEMs, etc. So the cost of equipment, cost of devices becomes less by using the economy of scale concept which we have. And once ITU identifies a particular band, for example, in our case, 3GPP has developed 5G.
This is not clear, sir.
Sir, please see the chat box.
Once I finish one or two slides so that there is a continuity, I'll definitely look at chat.
Sir, voice is not
Voice is
audible.
not clear.
In between, it is
Okay.
muting, sir. Voice.
Okay. So let me then try with mobile data. So please give me a moment. I'll connect my mobile as a hotspot to the fiber which I have. Just give me a moment. Can you please confirm if the voice is still same or it has become okay? Can somebody confirm whether now voice
Now okay,
is okay
sir.
or
Better than
Now it's
better
okay,
than
sir.
usual.
We will observe for 5 minutes.
okay? So just tell me whenever there is a problem.
Yes, sir.
I have
Crystal clear.
connected hot. Okay, great. Okay, so this I talked about. Okay, let me take questions if you have in chat box. Let me take that. Okay. So I think I don't see any questions. It was about the voice break only. Okay, so so at what time ITU allocates the frequency bands? It's not allocation but identification. So basically, it is the WRC meeting, so World Radio Conference we call it. Every 3 to 4 years, ITU organizes a meeting called World Radio Congress, and in that meeting, all the member countries, you may be knowing that almost more than 190 countries are member of ITU, so they attend that particular conference. There's a lot of preparation goes on, and in that particular conference, they decide whether some additional frequencies are to be allocated for IMT, and they also talk about the satellite orbit and other aspects of it. So the last WRC meeting, the World Radio Congress meeting, was held in 2019. As you can see, just a moment. Let me take reading. So this is WRC 19, and this was held in October, November. In that meeting, they had identified additional bands in millimeter wave. So what were those bands? Those were in 24 gigahertz, 24.25 to 27.5 gigahertz. Then they had identified 37 to 43.5 gigahertz, 45.5 to 47 gigahertz, 47.2 to 48.2, 66 to 71 gigahertz. So these were additional bands which they identified for INT. Please note, whenever IQ identifies, they identifies for INT. They don't say 3G, 2G, 4G, 5G, but primarily they considered requirement which was going on for 5G. Right? So, and these are also being, some of it are being used for 5G. Okay, so if you look at these total bands, so prior to this WRC 19, total frequency channel bandwidth, if you add up, allocated for mobile or INT was only 1.9 gigahertz. And with this allocation, it became 17.2, please note down this, 17.25 gigahertz. So you can just imagine that it's almost 8 times increase from the previous location or previous administration by ITU. Okay. There is one message about the voice break. Please confirm whether you can hear me. In the chat box, yes or no, you can write. Whether voice is clear.
Voice is clear, sir.
Hello.
Thank you.
Voice is better.
Sir, there is some background disturbance is going on. That's it. Though the
For
voice is
that,
clear, but some.
I request other participants to kindly keep your mic in mute mode. That's the only thing you can do it. Maybe Atul can mute if some participants' mic is on by mistake. So now that ITU has allocated or identified additional band, so as you know that 3GPP, they developed 5G technology as part of their release 15, and thereafter they have gone to release 16 and 17 as of now. So they identified two frequency ranges. So not all the bands which was identified by IT will be used immediately. So as technology gets developed, we use that. So they defined two frequency ranges. So please remember. So the one is called frequency range 1. Frequency range 1, FR1. So this is a terminology used by 3GPP. And this FR1 consists of the frequency band starting from 410 megahertz and goes up to 7.125 gigahertz. Up, I mean, this was in release 16, right? In release 15, this was starting from 420 and it was ending at 6 gigahertz. That's why in many of the literature or presentation by other speakers, you will hear this as a 6 gigahertz or sub 6 gigahertz kind of a concept. But in release 16, this was expanded up to 7.125 gigahertz and started in 410 megahertz. So that means all the frequency band which 2G, 3G, 4G were using, those are definitely used for 5G. In addition, certain new bands were also identified in frequency range 1. So what were those frequency band? Those were, let's see this, band N78 was a new band. Band N77 is again a new band, and band N79 is again a new band. So three new bands three new bands in FR1 range were identified, specified by 3GP2 for 5G. And as I was discussing, in India, we auction frequency band from this, from 3.3 to 3.8 in 78. Across the globe, this is the band being used by all the almost all the operators, right? Now, let me ask you a question. From N78 band, how much bandwidth were required by Jio and Airtel, if you have any answer from N78 band? Can you answer in the chat box if you know that how much bandwidth from N78 Airtel and Jio has acquired? Vodafone has acquired very little, so let us not talk about that. Okay, so I got one good answer. Somebody is saying 400 megahertz. So answer is 100 megahertz. Answer is that 100 megahertz of the channel bandwidth is acquired by Airtel as well as Jio from N78 band in all the LSA. So we have 22 LSA in our country. Normally, LSA is co-terminus with the state, but smaller states are combined and made one LSA. So in every LSA or service area, operators have acquired 100 megahertz from N78 band, and that they have actually deployed. So let me ask one more question from all of you, that if you recall earlier, the spectral efficiency of 5G was 30 bit per second per hertz. Bit per, and you have 100.
Sir, voice gone again.
Yes, sir, voice problem.
Sir, can you please disconnect and again join back, sir? Leave the meeting and again join back, because that could resolve the issue, I think.
After joining, please repeat this slide.
Everyone, please wait. This connection issue is being taken care of.
Am I audible? Can you confirm?
Yes.
Audible,
Yes,
sir?
audible.
Yes, sir. Audible.
Yes, sir, you are audible.
Okay. Sorry for the network issue today.
Yes, sir,
So
audible, sir.
fiber is also giving trouble. Okay. So my question was, somebody also answered. I'll repeat that question so that you are able to understand and answer. What I said, in N78 band, operators have acquired about 100 megahertz of the frequency. And in 5G, we have 30 bit per second per hertz of spectral efficiency, peak spectral efficiency. So how much peak data rate our operators will be able to achieve? So they were good answer. If you multiply this, you'll get 3 Gbps, and that's why 3 Gbps the peak speed and overall speed. That's why if you have a 5G connection and today if you do a speed test, so many places we are getting 400, 500 Mbps, which is good. Okay, so that is about frequency range 1. Now let us talk about frequency range 2. So frequency range 2 is from 24.25 gigahertz to 52.6 gigahertz. In this band, this is a new band, if you recall. This is completely a new band. So it is. So there are 4 bands. If you look at the below picture, N258, N257, N261, and N260. These are the 4 band identified. In India, if you recall, it is the N250 band, which was auctioned. This is the N258 band, which was auctioned. And can somebody guess that how much channel bandwidth or spectrum bandwidth was acquired by Airtel and Jio? Airtel and Jio, how much spectrum they acquired in the auction? Somebody says 400 megahertz, somebody says 200 megahertz. I think then let me answer. Airtel acquired almost 1000 megahertz, that is 1 gigahertz, in almost all the LSA, and Jio acquired, in some LSA they acquired 800, and Jio acquired 1000 megahertz, that is 1 gigahertz, and 1200 megahertz. Few LSA they got 1200, and most LSA they have 100 megahertz. So they have got, it's not 100, it is 1000. So people are answering 100, it is 1000 and 1200 megahertz which they have acquired. And as Jaipalji was telling that in the higher frequency bands, we have enough channel bandwidth. So that's why we have allocated and operators have acquired. So now with this millimeter wave, you can achieve the speed which is desired, or which is, and which says for 5G, if you recall, the peak data rate defined for 5G was 20 Gbps, right? 20 Gbps. So to summarize that, in lower side of the band, operators would be using 700, 900 megahertz band. And in this band, they'll be using only 20 megahertz, because lower side we don't have much spectrum. In the mid band, which is N78 or 3.5 gigahertz, operators will be using about 100 megahertz band. And in millimeter wave, which is 258 and 258 or 26 gigahertz band, here they have 1000 megahertz. So they will be using combinedly, they may be using carrier aggregation, and they will be able to offer you very, very good service using all the 3 spectrum which they would be having. So look at this particular picture. I hope you are able to see this slide. So can you see this bands on your screen?
Yes.
Yes. So just see the nomenclature. Nomenclature of these new radio operating bands. These are called N1, N2, N3, N5, N7, N8, and so on. So these are various bands which are identified for 5G. Not all bands will be used by all operator or all countries. So these are various options which 5G would be supporting. So just look at this frequency, and most of the frequencies which are here on the upper side, they are already being used by 2G, 3G, 4G, and 5G, and that can be used for 5G once you are able to spare or refarm those frequency. So just look at this. The frequencies here up to this all are defined as FDD band. What is FDD? Can somebody answer? What is FDD? FDD is frequency division duplexing.
Division duplexing.
Yes, and that's why you have spectrum.
वो भी नहीं है. अभी तो वो भी
for,
गायब है.
so can you mute your mic? Please mute your mic. Thank you. And in downlink, you have a separate frequency. Just see that in N1 band, uplink side, we have 1920 to 1980. In downlink side, we have 2110 megahertz to 2170 megahertz. Similarly, in 1850 to 1910, we have 1930 to 1990 megahertz. So these are FTD band. Then you have TDD band, time division duplexing. So these bands, if you look at N34, N38, these are, of course, older bands. So these are time division duplexing bands. So all the band identified later, most of these bands are kind of time division duplexing. All our initial system was made FDD. Then again, here you have FDD, some bands, right, in N66 and 70, 71, and so on. Now there is something special called SDL. Can somebody guess what it is? What is SDL? Can somebody guess what is SDL? In 5G, we have concept of something else.
Maybe single download SDL. Link.
Okay, any more answers? So this is called supplementary downlink. These are supplementary downlink. Atul Jain have answered correctly. So, and you can also see that these bands are given only for downlink. Uplink is written as not applicable. So basically in 5G, what is allowed is that you can have additional frequencies only for downlink. So that is a possibility, and use cases we'll see later today, but you can use only for downlink. Now just see certain frequency band. Again, you have, so let us look at these bands, N77, 78, and 79. And as I said, these are kind of new bands identified in the mid band for 5G. Let's see that. In our, and these are TDD bands. So please remember that all the new bands are TDD bands. And we are using this one, 3300 megahertz to 3800 megahertz in our country. In some places they'll be using N77, and some places they may be using N79, depending upon what they have. Now I seek your attention for band 80, 81, 82, 83, 84. And the name written here is SUL. Can you guess what it is? Can you guess what it is? You can, it's a similar
supplementary uplink.
So in 5G, there is a provision made for supplementary frequency band only for uplink. That's why you see that these data are given in uplink, downlink it is not applicable. So it is possible that you can allocate certain frequency band only for uplink. Now again, if you see millimeter wave band, which are N7, 257, 258, 260, and 271, These are all TDD bands. You can see the same band is written both sides. Same band is written in uplink and also downlink because it is time division duplexing. So these are identified band up to release 16. So this table I have taken from standard and taken from the release 16. Release 17, perhaps they have identified few more bands. You can just look at those documents and understand what new band has come. Okay, so a small quiz for all of you. Frequency band supported in 5G, only low band, only mid band, only high band, or all the three bands? Please answer.
All the
You can write in chat box. So you can answer
low,
either
medium,
A,
high.
B, or D. All. Yes, yes. Very right. Very right. I think there is one more question. So everyone is writing correctly. There is one more question coming. Okay. So just tell that in 5G network, MM wave is used for capacity, ultra high capacity, or coverage. What is the prime use of MM wave? Please write your answer in the chat box. Please write your answer in the chat box. Yes, very right, very right. Yes, B is the answer. You're right. If I write A, B, C, then B is the answer. Correct. Very good. Okay. Again, so which are the duplexing mode used in FR2 band? Just read the question. In FR2 band, which we saw, band 258, 259, 216, 261. What is the duplexing method used? So your answers are correct, which is TDD. Yes, very nice, very nice.
USL, SDL, FDD, TDDs.
No, in FR2 we use only TDD. In FR2 we use only TDD. Just recall this. In FR2 frequencies are these, more than 24 gigahertz, and these are all TDD. Okay, good. Okay, so now let's come to our second topic. What is the channel bandwidth supported in 5G? So this we had talked about earlier. So please mute your mic when you are speaking or phone or your mobile. So just look at this picture. So as you recall, we said that we have two frequency ranges in 5G. The first is 5G frequency 1. So if you are using frequency range 1 for your 5G rollout, then you can have channel bandwidth of 5 megahertz or 10 megahertz or 15 megahertz, 20, 25, and then in the 10 megahertz size, 30, 40, 50, 60, 80, 90, and then 100 megahertz. So just see that 5G supports up to maximum of 100 megahertz channel bandwidth in FR1 range. If I talk about FR2, frequency range 2, which starts from 24 gigahertz and goes up to 52 gigahertz. So their channel bandwidth minimum is 50 megahertz, then can be 100, 200, or 400, depending upon the availability of spectrum with the operator they can utilize. So as we had seen that in India, operators have 20 megahertz in 700, that is FR1 megahertz. So they can use this channel bandwidth. In mid-band, in 3.5 gigahertz, they have about 100 megahertz channel bandwidth, so they can use this one. And in FR2, they have 1000 megahertz available, so they can use even 400 megahertz or less and use carrier edge, so they can have create 2 or 3 carrier component, and they can use carrier aggregation so that they have more than 400 effective channel bandwidth of more than 400. This is the concept. So to summarize, so minimum channel bandwidth in FR1 is 5 megahertz, and in FR2 it is 50 megahertz. Maximum channel bandwidth in FR1 is 100 megahertz, and FR2 it is 400. Okay. So again, question: what is the maximum bandwidth in FR1? Please answer in the chat box. So I think I will. Yes, good, very nice. Let me pause here and take your questions. So if you have any questions as of now, I see some raised hand. So you can ask your question and then I proceed.
Ashok sir.
Yes, please go ahead.
Ashok sir, I'm R.K. Chaudhary. I just wanted to know, sir, the commercially available 5G handsets as of now in India. What are the bands which they are supporting? 77, 76, and I think 79. So what are the bands which they are supporting?
So a very good question. So when we buy our phone, 5G phone, so we should definitely look for N78 band, because this is the band being used in India. And also if you go outside country in a roaming environment, since other operators are also using, your phone will continue to work. Then in India, Jio is creating a large network. So they are using 700 megahertz band, which is called N28. So you should look for N28 band while you buy a phone. In millimeter wave, as of now, I think no commercial phone is available, or if it is available, it is very, very costly. Whereas maybe after 5-6 months, we'll have certain phones in N258 band. In addition, since your 5G phone will also support 4G, 3G, 2G, so your phone supports all technology, right? Your user equipment supports all technology. So whatever 4G band, 3G band, 2G band that it will definitely support, it will have, because those are already matured. So we should look for these three bands, these two bands at least in India. And also there are phones which like they may support only standalone operation, or they may support only NSA. Since in India we have NSA, NSA both, so we should buy a phone which supports both as of now. Initial phone which came for launch of 5G, they were just NSA phone, so they may not be working in Geo environment. But nowadays, all phones are coming supporting SA and NSA. So, and now most of the phone which you buy would actually support the required band. So whatever launches are happening in India as of now, they are taking care that all the bands where 5G is being launched and 4G, 3G, 2G is operating, they support. And more the number of channel bandwidth your phone is supporting, your cost will be high. So if you look at the Samsung phone, they're higher side models. So they may cost you 80,000, 1 lakh, and so on. But all because they are supporting so many bands. I mean, those phones are some sort of international phone which operates in many countries. So they may cost you more. They are also supporting carrier aggregation up to certain number of carriers. So that's why the cost, because of the electronics, cost increases. But the phone which is available in India for 15K onwards, they are good enough for our country as of now. So you can buy any phone. All phones are supporting now, and most of the phone coming now is 5G supported.
So sir, yeah, please sir, carry on, sir.
If you have any supplementary questions, sir.
Yeah. So I should look for a N78 and what is the other band you said, sir? Which two bands?
28 and 78, sir.
Okay, sir. Thank you, sir. Thank you.
Sir, I have a question, sir.
Please.
Sir, what I have seen, above some 3 gigahertz, there are no FDD system. Why it is so? Only TDD is there.
So higher. So as we had discussed earlier, that although the initial telecom systems were made for FDD because TDD was not possible because of the less compute and less technology we had. TDD is always better for more spectral efficiency, all because we can allocate more spectrum for downlink or uplink as the requirements are. So all the new band allocation would be in TDD. When implementation of TDD is a bit complex compared to FDD. It's a clean implementation in FDD that you have separate frequency for uplink and separate for downlink. When you use for both, a lot of complexity comes. So nowadays we have enough of those algorithms, enough of those compute, etc. in mobile otherwise. So that's why all the two bands will be in TDD most of the time.
Okay, sir. Thank you.
Any more questions or shall I proceed?
All the operators use TDD for better use now? In the
depending upon what spectrum they have. In 5G, since they have N35 and N35 is the TDD band, and they have actually acquired that kind of band, so they have to use. 700 megahertz band is an FDD band. So for 700 megahertz, they'll be using FDD. 900. So all those previous bands are actually defined as FDD. So they have to use it because all equipment, all ecosystem are for FDD. So depending upon which frequency they are using, so it will be mix of TDD and FDD as of now in 5G.
Sir, the maximum bandwidth in FR2 is 400 megahertz.
Yeah.
Operators are having 1000 megahertz. What may be the purpose, sir?
So they can use carrier aggregation, right? So they can use, suppose one 400 megahertz channel bandwidth and other component from the same band, 400 megahertz band, then maybe 200 megahertz band. So they can use three different chunk of carrier component from the same band. They can do carrier aggregation as and when required. So wherever required, wherever high capacity of the data rate is required, they can actually use that. Multi-layer of transmission would be possible with that. And there are various possibilities. That suppose in a network I am transmitting 3 carriers simultaneously. Some of the users are here. Instead of dividing all users on 400 megahertz, you can also divide those bands among group of customers. So your overall capacity of the network.
Yes, yes, sir.
Okay, so let me move further. So we are at third part. So what kind of waveform and modulation which we are using in 5G new radio? So
sorry to disturb. Ashok sir, sorry to disturb you. I do have a very small query. Likewise, we do have the supplementary uptime and the downlink channels, which has been separated out. So can we use that for the carrier aggregation with the conventional bands?
Yes. Answer is yes.
Okay. Thank you, sir.
Okay. So let us talk about waveform and modulation used in 5G. So the waveform which we use in 5G, we call it orthogonal frequency division multiple access, and it is similar to 4G. In 4G also we were using OFDM waveform. Even in WiMAX we had used. Even in Wi-Fi thing which you have at your home uses orthogonal frequency division multiplexing. So before we move forward, let me ask a question: that why we call it orthogonal? Can somebody answer? Can somebody answer why we are calling this as an orthogonal signal? You can see this in the picture. Any answer from any of you?
Sir, because
there are many participants from even engineering colleges.
Because when one signal reaches maximum, other
please write in the chat box.
There is 0. Dot product is 0.
Better to write in a chat box. Yes, somebody is writing. Yeah.
90 degrees.
Okay, good, good.
Phase shift is 90 degrees, sir.
90 degrees.
Okay. So, so basically, whenever there is a peak of one, so let me first explain how we make this kind of waveform. So basically, suppose you have, suppose you are given, say, 5 megahertz of channel bandwidth, 5 megahertz of channel bandwidth. So what you do, you divide your channel bandwidth into subcarriers. And in 4G and also in 5G, one of the subcarrier we use is 15 kilohertz, right? So we divide the 5 megahertz channel into small subcarrier of 15 kilohertz. So if I divide this 5 megahertz, so I get so many subcarriers. So these colorful waves you see are nothing but subcarriers, and the distance in frequency domain delta f is subcarrier spacing. So in my example, which I'm telling about, suppose it is 15 kilohertz. So that's why we make it OFDM signal. So whenever there is a peak of one subcarrier, just see, this is the peak of one subcarrier. At that point of time, there will be null of all other subcarriers. Just note this point. Whenever there is a peak of one subcarrier, there is a null of all other subcarriers. That is the beauty of OFDMA, and because of this property, you will not have interference, and that's why we call it orthogonal. That's why we call it orthogonal. Yes, R.P. Singh Saab has answered very rightly. Okay, and then what kind of modulation we use? What kind of modulation we use in 5G? So it is, yes, it is QAM type of modulation, quadrature amplitude modulation. So we support QPSK 16 QAM, 64 QAM, and up to 256 QAM. So this I'm talking about release 15 and release 16 of 5G. Whereas if you go beyond these releases, this order of modulation will increase. So we are using QPSK, that is 4 QAM, 16 QAM, 64 QAM, and 256 QAM, up to 256 QAM in 5G. Okay, let me erase them. Yeah. So let us just compare that what is the difference between frequency division multiplexing and orthogonal frequency division multiplexing. So in all of you would be knowing, but just to for the sake of understanding, in frequency division multiplexing, the available spectrum we divide into a small chunk of the frequency. Right? We also call it channel, leaving some guard band in between, leaving some guard frequency band in between. Right? In case of an orthogonal frequency division multiplexing, since my signals are divided into subcarriers and subcarriers are orthogonal, I don't need a guard band. So the orthogonal frequency division is utilizing the spectrum in a much better way compared to FTN. And since these are divided into small subcarriers, so the propagation property also improves because of this compared to if you use a larger frequency for that. Okay. So now there's a question for all of you. So suppose I have channel bandwidth of 50 megahertz. Yeah, I have a channel bandwidth of 50 megahertz. I have subcarrier spacing of 15 kilohertz. And I have to use guard band of 692.5 kilohertz. Guard band of 692. So what I'm saying is this one. I have a channel bandwidth of 50 megahertz. Suppose this is 50 megahertz from here to here. but I have to leave certain guard band on both sides. And this guard band on each side is about 692.5 kilohertz. So now question to you is that you calculate the transmission bandwidth, that if you subtract channel bandwidth from channel bandwidth, the guard bands from both sides, you will get channel bandwidth. So can you calculate the channel bandwidth and tell me how much it is coming? The transmission bandwidth, how much transmission bandwidth you are able to get? Can you answer in the chat box? You have to just subtract 692.5 twice from the 50 megahertz. So Puma S have answered. Any more answer, please? You can use calculator or whatever device you may have.
48615 kilohertz, sir.
So yes, you're right. Good. So I got only 2-3 answers. So please use chat box. Yes, very right. So it is 48.617 or something you will be getting. Now the next, we have to calculate how many number of subcarriers I can get. Can you calculate number of subcarriers? So now you have to divide this figure by 15 kilohertz. And then you get the number of subcarriers. So please calculate. Yes, very nice. So Vinodji, it's not 3, 4. It is, you have to divide by 15 kilohertz. Please mind the megahertz and kilohertz. You have to put 3 zeros in megahertz to make it kilohertz. Yes, very nice. Most of you have answered 3241. So with 50 megahertz channel bandwidth, I'll have 3241 subcarriers. In this picture, you can see only 4 subcarriers, but I'll have 3241 subcarriers if I use 15 kilohertz subcarrier spacing. Okay, good. Now let us recap various modulation just for the purpose of understanding. If you, what are you asking? Let's move. So let us recap the modulations. You might have gone through all these. So we have amplitude modulation. In amplitude modulation, depending upon whether I want to transmit 1 or 0, the amplitude of the signal is varied. In case of say 1, I have a larger amplitude. In case of 0, I have less amplitude. So that is your amplitude modulation. In case of a frequency modulation, you use different frequencies. For example, for 1, you are using a lower frequency. For 0, you are using slightly higher frequency, and so on. Then you have a phase modulation, wherein you change the phase. For 1, you are you are using 0 degree phase, and then for 0, you may be using 270 or any other phase. So based on the phase you are modulating. And if you combine this amplitude and phase, so like this, so that becomes your QAM kind of modulation. So in 5G, as I discussed, that we are using quadrature amplitude modulation. So if you look at this kind of picture, so in quadrature amplitude modulation, let us talk about 4 QAM, or that is also called simple QPS scale. So we have, what we do is that we have this much amplitude and it has got this much phase, this much degree. Right? The other position is this is the amplitude, but so this is the, I mean, you can see the angle. So your phase is changing. So your phases are different. The amplitude are either in plus direction or minus direction. So what I'm trying to say with QAM 4, I have 4 positions. So I can transmit 2 bits. May I request somebody has opened the mic. Atul, can you mute him?
Yes, sir. I'm listening.
in attendees side, you can use mute all. If you have
Yes.
access,
Yes.
where you see attendees, you just
Yes.
click. Still coming. Should I do it, Atul?
Done, sir. Done.
Thank you. Thank you. Okay. So you have 4 positions with different amplitude and phase combinations. So you can either transmit 0 0 or 0 1 or 1 0 or 1 1. That means 2 bit per symbol will be able to translate, right? In QPSK. In 16 QAM, you will have such 16 points which will have a different phase and amplitude, and that's why you have a 16 combinations. So 16 combinations you can represent 4 bits. Like you can start from 0 0, then 0 0 0 1, and you can go up to uh, uh, the last 1 1 1 1 type of. So you'll have a 16 such combination. So 4 bits per symbol can be transmitted. Similarly, for 32 QAM, you can transmit 5 bits. Basically, 2 to the power you can calculate. For 64 QAM, you can have 6 bit, and then for 128 QAM, you can have 7 bit per symbol. You can calculate. So okay. So here, my question is to all of you. Most of you are from engineering institute and all. That when when I told you about which QAM being used in 5G, I told you that we can use QPSK 16 QAM, 64 QAM, and 256 QAM. We didn't talk about 32 QAM, or we didn't talk about 128 QAM. What is the reason that these QAMs are not being used in 5G? Can you guess any reason? This question is that in previous slide I said that 5G supports 4 QAM, 60, 16, 64, and 256. They are not using 32 QAM or 128 QAM. Bits are odd numbers. Any more answer? Not because of that. So we can create these structures are made which can be used. Okay, then let me answer. Let me try to answer. All because actually when you suppose transmit a 32 QAM signal, so generally what happens, suppose you have a tower, so higher order modulation will be able to decode only when there is a good signal, suppose at this place, not onto the outer coverage. So suppose this is the point. So it is observed that suppose you transmit 32 QAM and you are able to decode here. At this point, you are also able to decode 64 QAM. Right? So basically, there is no gain using 32 QAM, but at the same position when I can decode 32 QAM signal, I can also decode 64 QAM signal because of the structure which you have, right? Just see the structure practically. Similarly, when you use 128 QAM and the points of the distance where you can decode it, there you can also decode 256 QAM. So there is no advantage using 128 or 32. In place of that, you can use 256, wherein you can have more number of bits, like from 128 to 256, you'll have more number of bits support. So that's why we use all those QAMs which are like 16, 64, 256, and so on. go further. So every position represents a bit. So this is a 16 QAM example where this particular point, which has certain amplitude and phase, may represent is all 4 zeros, 0, 0, 0, 1. Then you have 0, 0, 1, 0, then 0, 0, 1, 1, then 0, 1, 0, 0, and so on. So these are positions, and then we go up, and these positions represent a particular bit. Okay. So how WaveDM system works is a big topic. It's a very a brief thing which I would be telling you about. You might have read these into your engineering study. So practically what we do is that your data is coming the serial data. Your data will be in the form of 0, 1, 1, 0, 1, 0. Some serial data is there. In 5G, since you have concept of subcarriers, so like you have n number of carriers, we have calculated 3000 subcarriers. So what we do is that some data will go to one subcarrier, will modulate the data onto the subcarrier. So what we are trying to make, we are making the serial data into parallel, putting suppose it is just an 4 QAM. So maybe first digit, 2 digit gone here, next 2 digit is gone here, next 2 digit is gone here, next 2 digit is gone here, because it is supporting. So you are making this serial data into parallel data, and then you are kind of this baseband signal you are converted into the carrier frequency and sending onto the network. So that's a broad concept, but here what we do that after the cancellation into QAM, we do the operation called inverse of fast Fourier transform. You might have heard Fourier transform in your engineering school colleges. So at the transmit side, we do an inverse of fast Fourier transform, and then we convert this digital data into analog data, and we send it onto the carrier. On the other side, when it receives, so we back convert the analog data into digital data, and here we do fast Fourier. Here we did inverse of fast Fourier transform. Here we are doing FFT, and then on the back we are able to demodulate the signal. Same diagram shown here. That here we are mapping QAM source onto n orthogonal subcarrier, which I explained here. Then we are doing IFFT, inverse of FFT, and then we are summing up all those subcarriers into one and transmitting onto a carrier channel. As receiver side, we do FFT, and then again we convert frequency diameter QAM and decode the data. So this is a broad. There are many book and article in detail about this. If you have interest, you can go through. I can also give you certain data. Okay, so maybe I can take questions before I ask any question from you. Any questions which you may have? Do you have any question? Okay. Okay, so you answer this. Number of bit per symbol in 256. Your answers are correct. Very right. Good. Okay. So I'll take another 15 minutes of the session. 1 p.m. we can break, because 2 p.m. onwards we again have session. So today is a power pack day, so please bear with us. 1 to 2 I'll be giving the break. Okay, so let us now understand. Do you have any question? I see raise hands. If you have any questions, please ask before I proceed. Anyone? Okay. Okay, let us look at the concept of numerology, subcarrier spacing, and resource block in 5G. Okay. So what is numerology in 5G? Let us first understand. There is a concept called numerology. It's a simple concept, but by name you may get confused. So as we all know and discussed that 5G uses orthogonal frequency division multiplexing kind of waveform, and it uses the variable subcarrier spacing. Earlier example which I gave was a 15 kilohertz, but that size subcarrier spacing is variable in case of 5G. And if you recall 4G, if you know 4G, in 4G we use 15 kilohertz subcarrier spacing. In 5G it is variable. That means we use 15 kilohertz. We also use 30 kilohertz series. We use 60 kilohertz. We use 120 kilohertz, and we also use 240 kilohertz. We use different subcarrier spacing for different use cases, different spectrum, which we will try to understand in upcoming slides. So there is a question by Sumit that what is IFT, inverse of fast Fourier transform and fast Fourier transform. It's a method of a kind of doing QAM modulation onto the subcarriers. It's a big topic. There are books available on this. I'll be sharing that for if you want to study more on that. For time being, basic things I have explained. Okay. So let us look at what is numerology. So basically, just look at this. 2 to the power mu into 15 kilohertz you find as a subcarrier spacing, and here mu is your numerology. Mu is your numerology. So suppose if mu is 0, suppose mu is 0, that means your numerology is 0. So what will be the subcarrier spacing with the formula? 2 to the power 0 into 15. Please answer in chat box.
Excuse me, sir. The voice is breaking.
Okay, good answer. So I got answer of 15 kilohertz. So that means when I say numerology 0, I'm saying that 15 kilohertz subcarrier spacing. So let us calculate. A is equal to 1. Numerology is equal to 1. Then what will be the subcarrier spacing? That is 2 to the power 1. Mu is 1. And then 15. How much I'll get? Yes, good answer. 30 kilohertz. So when I say numerology 1, I mean that subcarrier spacing is 30 kilohertz. What is numerology 2? Numerology 2, what will be the subcarrier spacing? 2 to the power 2 into 15 is, yes, lot of answers are coming. 60 kilohertz. And what will be the numerology 3? 2 to the power 3 into 15, it will be good, 120 kilohertz. Somebody is saying what is numerology? Numerology is nothing but subcarrier spacing. And then what is mu is equal to 4? That is 2 to the power 4 into 15 is your subcarrier spacing. Is nothing but 240 kilohertz. So we use these numerology. Numerology 0 to 4 in 5G. In 4G, we are using only 15 kilohertz. Where in 5G, we are using 5 such numerologies. Okay, let me take any questions which any of you may be having at this point of time. Any question, please? Any question if you have at this point of time, you can either ask in the chat box or you can open your mic. Okay, good. So no questions. So let me proceed further. Okay. So what is resource block? Can some of you answer? Those who know 4G, they would be knowing what is resource block. Okay, let me tell about it. So as we know, subcarrier spacing is this. So 12 consecutive subcarriers is equal to one resource block. What is RB? 12 subcarriers is equal to one RB. And what is specific? It shall be consecutive. You cannot take one subcarrier from here and one subcarrier from other place. It has to be consecutive, right? So RB is one resource block which consists of 12 consecutive subcarriers. So you have numerologies as 15 kilohertz, 30 kilohertz, 60, 120, and 240 we discussed, which is nothing but numerology 0, 1, 2, 3, and 4. So if you have to calculate the bandwidth of, suppose I have to calculate bandwidth of each RB for different. So suppose RB I said 12 consecutive subcarriers. So RB bandwidth for numerology 0 will be how much? 12 into 15 kilohertz. How much it will be? Please answer in the chat box. So bandwidth of a RB if numerology is 0 will be 180 kilohertz. Very right answer. So there will be 12 into 15, 180 kilohertz. Now suppose numerology is 1. So RB for numerology 1 will be how much? 30 into 15. What will be the bandwidth? Please write in the chat box. Yes, now I have double the bandwidth. Now I have double the bandwidth of 360 kilohertz. My RB bandwidth has actually doubled. Similarly, for numerology 2, what will be the bandwidth? RB bandwidth? Can you calculate? Yes, 720 kilohertz. So my bandwidth of RB is doubling and doubling when I go in higher in the numerology, starting from 180 kilohertz and goes up to 2880 kilohertz. So the bandwidth of my RB in 5G depends upon the numerology. What is the numerology? And then we calculate what will be the bandwidth of an RB. Good. So I think you have understood the concept of resource block. Any question? Shall I proceed? Okay, good. So now it's your turn. So suppose channel bandwidth is 100 megahertz and we have numerology 2, that means subcarrier spacing of 60 kilohertz. And here guard band for this we use as a 1370 kilohertz. So that means I have a total frequency like this, which is nothing but 100 megahertz from here to here. But I have to minus this guard band, which is nothing but 1370. So please calculate the transmission bandwidth. Please calculate. So you have to subtract the guard band twice from 100 megahertz. So please calculate and write in the chat box. Everyone, please. Everyone, please. Nidhi Sahab has written. Mangesh Sahab has written. All of you, please. All of you. Mayank has done it. Okay, good. Anybody else? Only 3 of you. I think it's time for lunch at APS. Yes. Now I see a lot of answers. Yes. So you guys are right. You guys are right. So now 97.26 is the right answer. Now you calculate number of subcarriers. Divide this by 60. Please divide this by 60. Please divide this by 60. You'll get number of subcarriers. Please answer. Please divide 97.26. You have to put 3 zeros also because of you to convert into and divide it by 60. You'll get number of subcarriers. Please answer in the chat box. Quickly, please. So you divide 90. Yes. Ravinder Saab. So many answers. Kamal, Pooja, Mangesh ji is there. Vinod Sharma ji, Madan. Lot of answers. Very nice. Very nice. So now that you have number of subcarriers with you, which is 1621. Now, how many RB? Please take only the and without decimal, you calculate the RB. You have to divide this by 12 because one RB is 12 subcarriers. So please divide by 12 and you'll get the number of resource blocks. Please calculate. So 1621 divided by 12, you'll get number of subcarriers. Yes, now I'm getting right answer. Now I'm getting right answer from many of you. Initially, there were some wrong answers. Yes, good, good, very nice. So 135 is your number of RB. If I have 100 megahertz channel bandwidth and use 60 kilohertz subcarrier spacing, the guard band is fixed or standard. Somebody has opened the mic. Please mute yourself. So please calculate bandwidth of all the resource blocks. So suppose numerology 0, what will be the bandwidth? Okay, so that question we had already answered. So I'm giving you one more question that if I have a channel bandwidth of 50 megahertz, subcarrier spacing of 30 kilohertz, guard band is 690.5 kilohertz, please calculate transmission bandwidth here. One more exercise for you. Just calculate transmission bandwidth here. Just calculate transmission bandwidth here. Anyone, please subtract 692.5 twice from 50 megahertz. Yes, I got the answer. And then you divide. So whatever answer you get, 48.615, you divide that by 30 kilohertz here because subcarrier spacing is 30 kilohertz here. Yes, please. Now you are getting transmission bandwidth. Now divide that by 30. Divide that by 30, you'll get number of subcarriers. So 1620 is the right answer. Many of you have it fully calculated. Great. So keep doing this exercise. So as you might have heard, this picture I had shown that if you move in numerology, your size of resource block is doubling. Okay, so now the question in numerology 2, what is the subcarrier spacing? Please write in the chat box. If we have numerology 2, what is the subcarrier spacing? 30 is not the correct answer. 0, 1, 2, yes. 0 is 15, not 30. 0 is 15, 1 is 30, then 2 is what?
60, sir.
It's not, yes, Sumit, not 180. Yeah, good, good. So it's 60 kilohertz. So just remember, when I say 0, numerology 0, it is 15 kilohertz. Numerology 1, 30, that's doubling. So to 60, if it is 3, then 120, if it is 4, then 240. Don't confuse. Okay, good. Now suppose we have numerology 4, then what is the bandwidth of RB? If we have RB of numerology 4, what will be the bandwidth? Please calculate. What is, first of all, you have to know what is the numerology 4. and then you calculate by multiplying it by 12. So Umaji, it's not correct. Atulji, it's correct. Yes, 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 yes. Good. So the last one is the right answer, 2880, because numerology 4 means 240. And if you divide this by 12, you get the 2880 kilohertz. Okay, so the topic which I'll be covering, which I left in the previous session, we will just discuss about relation between 5G numerologies, supported bandwidth, frequency bands, cell size, usage scenario. So let us first understand what is UV channel bandwidth. This picture I have taken from 3GPP standard itself, which you can find in this document. This is a very important document. You can download and understand whatever aspect I'm teaching. I have taken from this particular standard. So as we had also done calculation, so basically suppose you have channel bandwidth of in the morning we had discussed 100 megahertz, 50 megahertz. So from here to here, suppose you have this much of megahertz of channel bandwidth. So from this, from the both sides, we have to have certain guard band, which I had while exercising, we reduced guard band, right, from the channel bandwidth. And these guard bands are already defined by 3GPP in their standard. I'll also be showing those charts in the upcoming slides. So if you remove the guard band from both sides, whatever is remaining is called transmission bandwidth. Right? Transmission bandwidth, which will consist of certain number of resource block, right? And out of the all available resource block, some of the resource block will be active at a particular time. So this is the active kind of a transmission bandwidth, active number of RV, active number of resource block, which is a transmission bandwidth at that point of time. So this is the overall definition. So just to summarize, just understand that UV channel bandwidth supports a single NR-RF carrier, okay? And BTS part supports different UV channel bandwidth within the same BS spectrum. So when your BTS is transmitting, it will be supporting many UV who may be supporting different transmission bandwidth or channel bandwidth. But G node B is common for all the UV. And the third is that base station supports transmission of multiple carriers to the same UV or to the multiple carrier to different UV. That means tower or base station can do a parallel transmission, and suppose one UV is receiving both the signal and it has got capability of carrier aggregation, then it can consume both. Or it is also a possibility that some set of UV is receiving one kind of carrier and some set of UV is receiving other kind of carrier. This is the concept. And finally, UV is configured with one or more bandwidth part of the carrier, each with its own channel bandwidth. That means one UV can support one carrier, more than one carrier, and certain number of bandwidth part in each of these carrier components. Okay. So let us look at UV channel bandwidth. So we discussed in the previous slide. This is also taken from the same standard. So from total, from this place to this place to this place, we called it channel bandwidth, if you recall. And we are removing this guard band. And then whatever we are getting is the transmission bandwidth. But one thing we have to note and understand that I mean, we had a concept of RB. So in one of our calculations, we found that we had 135 RBs within the bandwidth which we have. The start point of, suppose this is in frequency domain. So your RB cannot just start arbitrarily at any point. So there is a defined start point. So suppose RB1 is started here, then we have RB2, RB3, and so on, like this. But suppose your transmission bandwidth is coming like this. Suppose it's coming like this. So this is your transmission bandwidth. So you cannot use this RB, right? You cannot use this RB because your transmission bandwidth is starting in between somewhere. So you can actual usable RB is from here and up to here, right? So that is what is called all PRB falling within UV channel bandwidth, not covering the minimum guard band, can be used. So these are the usable number of RB. So
sir, can you please repeat, sir?
Okay, sure. Let me erase them. Okay, what I'm trying to say, suppose you have, say, 100 megahertz of channel bandwidth, and with 100 megahertz, now suppose you want to use this, so you will divide into subcarriers and also divide into RBs. I mean, 12 subcarriers is RBs. So from the entire channel bandwidth, the start point of RB, one RB will start at some frequency point, right? It will not start at every point. So suppose it is starting from here, and this is your first RB, second RB, third RB, fourth RB, and so on. And there are many RBs here, right? But you have to consider this guard band. So you have to remove. Suppose this guard band is coming here. This guard band, left side guard band is coming here, and suppose the right side guard band is coming here. So this is what is my transmission bandwidth. From the channel bandwidth, I get this transmission band. Since this guard band is coming here, I cannot use this RB, although some part of it is in, I cannot start my RB from here, right? The next RB will only start here, and I cannot use this RB because in between you have a guard band. So you can use up to this. So this is the effective number of RB which can be used. Is it clear now?
Yes, sir. Yes, sir.
Great. Okay, now let us look at second concept. These are available in the standard document. You can always refer to. Just see this picture. We had discussed about various numerology 0, 1, 2, 3, and 4. So two things I want to explain. So in a channel bandwidth, suppose you have a channel bandwidth. Within channel bandwidth, some part you can use for numerology 0, other part you can use for numerology. So mixed numerology use is possible in 5G. So here in this example, what is shown that, okay, from both sides, we have removed the guard band, and whatever is left out, we have divided in two parts. In one part, I'm using numerology X. In other part, I'm using numerology Y. Let us assume this is 15 kilohertz subcarrier spacing, numerology 0, and this is 30 kilohertz, which is numerology 1. The second aspect which I want to tell you that the guard band size depends upon the numerology. So here, if you see, the guard band size is less compared to the guard band size here because of the numerology. So that means if you read guard defined for numerology X when transmitted across full UV channel bandwidth, and this is the guard defined for numerology Y. So depending upon numerology, your guard band is varying. You may be having the same band, right? So the guard band is depending upon the numerology. Okay, now let us look at this chart very carefully. Everyone, please give your attention. I'll be asking so many questions after I have explained this. So on top table, this table is also taken directly from the standard. I'll make you understand, right? So this is the maximum transmission bandwidth configuration. How many RB we can configure in a given channel bandwidth. So suppose I have 5 megahertz of channel bandwidth, and we have done the calculation. So 5 megahertz, first I have to remove the guard band. So guard band is defined in below table, this table. So these are the guard bands defined. So suppose my numerology is 15 kilohertz, that is numerology 0. For numerology 0, my guard band is this much, 242.5 kilohertz. So I will remove 5 megahertz minus this twice, and whatever is left, I will divide by 12. So I'll get number of RB. So if you do this calculation, you'll get 25 RB. So in 5 megahertz, you will have 25 RB in case you are using numerology 0. Suppose you want to use numerology 1, which is 30 kilohertz. In that case, guard band defined for this for 5 megahertz is 505 kilohertz. So you will remove this much 505 from 5 megahertz twice, and then divide by 30, and then divide by 12, you'll get 11 number of resource block. You'll get 11 number of resource block. Please also note that in 5 megahertz channel bandwidth, they have not recommended to use 60 kilohertz channel bandwidth and beyond. You got my point? So this is how, so this in a tabular form, 3GPP has defined, although we did calculation in the morning. If you recall, we had done calculation for 50 megahertz and 100 megahertz. And 100 megahertz, we had used 60 kilohertz, so we had got 135 RB. You will recall that. Right? So let us look at some important summary of this chart. Just look at that 15 kilohertz sub-carrier spacing can be used up to only 50 megahertz channel bandwidth. Just see this correlation. 15 kilohertz sub-carrier can be used only up to 50 megahertz. Rest is given as a not applicable. If you have a 30 kilohertz sub-carrier spacing, you can use up to 100 megahertz channel bandwidth. Let's see this. Right. 100. And in 60 kilohertz sub-carrier spacing, also you can go up to 100 megahertz channel band. I'm talking about frequency range 1. I'm not talking about FR2. Please remember. This is not for FR2. I'm talking about FR1. That means all the frequency up to 7.125. So for every band, DGPP, I request Atul to kindly mute the person who is just speaking. Okay. So maybe I can pause and take any questions if you have any doubt in this particular table. Any one of you. Okay, so let us move forward.
Sir, calculation
This
understood,
table,
but what you want to correlate that not able to understand. Can you please repeat again? Calculation understood, sir.
calculation you have understood?
Yeah.
So here I am trying to say, if you want to use numerology 0, maximum channel bandwidth which you can use is 50 megahertz, because in 50 megahertz you will have 270 RB, but for 60 megahertz it is not defined by the standard. The standard do not allow you to use 15 kilohertz sub-carrier spacing with 60 megahertz channel bandwidth or beyond. So up to 50 only you can use. This is okay?
Yes, right.
Similarly, for 30 megahertz numerology, you can go up to 100 megahertz, and for numerology 2, also you can go up to 100. That is what I was trying to explain in FR1 range standard. Okay, let's go to the FR2. Let's look at this. There are certain important aspects. FR2 means all those frequencies which are from 24 to 52 gigahertz millimeter wave. So here, about 60 kilohertz, you can use. So just remember, 60 kilohertz sub-carrier spacing, that is numerology 2, was used in FR1 also. But in FR1, we were able to go up to 100 megahertz channel bandwidth. Here we are able to go up to how much? Up to 200. Just see, 400 it is not applicable. Let's see this table. So if we are using numerology 2, that is 60 kilohertz sub-carrier spacing, you can use a maximum of 200 megahertz channel bandwidth. You cannot go beyond that, right? In case you are using numerology 3, which is 120 kilohertz of sub-carrier spacing, you can go up to 400 megahertz. In 5G, this is the maximum channel bandwidth. So if you want to use 400 megahertz channel bandwidth, minimum sub-carrier spacing which you have to use is 120 kilohertz. So there is a relation between the channel bandwidth and which numerology you can use, right? And here it is the guard band. My question here is why here numerology 4 is not defined? Is there any reason for that? So numerology 4, as up to the release 16 and 17, is used only for the control signaling. So you can see here, not for the user data. So it is for only signaling, which is synchronization, signal block, PBCH, etc. So there they have defined as 240 kilohertz. That is numerology 4, right? And they have defined you can go up to 400 megahertz channel bandwidth. So is this clear to everyone?
Yes, sir.
Okay. So if you have actually understood, just tell me. I'll fill it up based on. Just a moment. I'll fill it up this table based on what you are answering in the chat box or opening your. So suppose if I have a frequency range 1, my sub-carrier spacing is 15 kilohertz. What is the minimum channel bandwidth I can use? The chat box or something.
5 megahertz.
5 megahertz. And what is the maximum I can use?
Maximum can be used as a 50 megahertz.
50 megahertz. Very right. And suppose I am using 30 kilohertz sub-carrier spacing. So then what will be the minimum in FR1? What will be the minimum channel bandwidth?
5 megahertz.
5 megahertz. And maximum
is 90
maximum
100 megahertz.
100 megahertz. Very right. Very right. And in FR1, if I have 60 kilohertz, what is the minimum channel bandwidth?
10 megahertz.
5 megahertz.
5 megahertz. 10 megahertz. Can we go back?
10 megahertz. Sir.
Yes, 10 megahertz. Just see this table. Here it is 10 megahertz. For 5, it is not applicable. Very right. Okay, it is not 5, but 10 megahertz, and it will go up to
100
megahertz.
100.
Right.
Okay, good. And for FR1, do we use 120 kilohertz?
242.5 ಬಂದು ಇದು ಗಾರ್ಡ್ ಬ್ಯಾಂಡ್
Do we use this?
ಇಂಟು ಟ್ವೈಸ್ ಮಾಡ್ತೀವಿ ಇಷ್ಟು ಬರುತ್ತೆ ಡಿವೈಡೆಡ್ ಬೈ ಸಬ್ ಕೆರಿಯರ್ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ
Right?
ಮೈನಸ್ ಮೈನಸ್ ಇದು
Sir, please mute.
ಬ್ಯಾಂಡ್ ವಿಡ್ತ್
Please. Thank you. Okay. Now let us go to the FR1. So in FR1, FR2 rather, do we use 15 kilohertz sub-carrier spacing? Yes or no? No, we don't use.
No, sir.
And 30 kilohertz?
No.
30 kilohertz also we don't use. 60 kilohertz, what is the minimum channel bandwidth? And what is the maximum channel bandwidth?
50 to 200.
50 megahertz. 200.
50 megahertz, and it will go up to
200.
200 megahertz. Okay. And what about 120 kilohertz? It will start from
50 to 400.
50 to 400.
We can go up to 400. And what about 240?
Use as an
100, 400.
100, 400, but use for control signal.
Okay, good. Hundred megahertz to 400 megahertz. Very nice. So we have done this exercise. Thank you so much. So this is the answer again. Okay, so to summarize this, in FR1, subcarrier 15 kilohertz will go up to 50 megahertz, 30 kilohertz will go up to 100 megahertz, and 60 kilohertz will go up to 100 megahertz. In FR2, we use 60 kilohertz subcarrier spacing, we go up to 200 megahertz. With 120 kilohertz, we go up to 400, and with 240 also, we go up to 400 kilohertz. Okay, this is very interesting slide, and this is taken from one of the white paper which Qualcomm has released. Now that we have understood subcarrier spacing, RB, different frequency ranges which we use in 5G. So this gives a snapshot about how these different subcarrier spacing, different frequency band are used in a combination. So on top, you just see the example. It is, they are saying example of 700 megahertz, that is M28 band. So this will be used for outdoor macro coverage, being lower side of the frequency. Will have a large coverage, so we'll be using for that, maybe for IoT kind of applications or rural coverage kind of application. In this scenario, the recommended use is of numerology 0, that is 15 kilohertz subcarrier spacing, and the carrier bandwidth or channel bandwidth which will be using can be used 5 megahertz, 10 megahertz, and 20 megahertz, depending upon availability and capacity which you are planning. So for umbrella coverage, for IoT coverage, for rural coverage, operators would be using lower side of the frequency with numerology 0, so that they have an outdoor macro coverage. Now coming to our midband. So midband, as we know that in India we have auction 3.5 gigahertz and it is TDD. So this can be used in a tier 2, tier 3, tier 1 cities for outdoor macro and small cell. So here recommended use is of 30 kilohertz, right? And the channel bandwidth of 100 megahertz. So in India also, you know that all operators have actually acquired 100 megahertz. So it's a sufficient spectrum they have. So with this configuration, they are actually deploying in the field similar or same configuration. Now, yesterday we had discussed that 5G can also use unlicensed band. So unlicensed band can be in 2.4, or they are talking about some other countries, they have 6 gigahertz also made unlicensed. So this is an example of that. And here you have about 160 megahertz of channel bandwidth. Carrier bandwidth available is 160 megahertz. So here recommendation is we use numerology 2, that is 60 kilohertz, and it is for indoor wideband coverage. Since it is an unlicensed band, you cannot have outdoor coverage. So although indoor coverage would be a possibility, so that can be designed. So your base station would be sitting inside your home, just like your Wi-Fi dabba. And for millimeter wave, they have given example of 28 gigahertz, can even be 26. So there they are saying use 120 kilohertz of the, that is numerology 3, and 400, complete 400 megahertz of the channel bandwidth. So this is how your frequencies, how your subcarrier spacing or numerologies can be used. This is just an example. This is not the rule, but an example.
Sir, is 600 6 gigahertz unlicensed band in India?
No.
As
It's
of
not.
now,
No, India is not unlicensed. It's just an example that how you can use. So it's an example of how different numerology can be used with different type of frequency bands. Okay, Mr. Om Prakash saying presentation not stable. Maybe I request you to disconnect and connect. It will become okay. Okay. So
To the
please.
power and slicing of sub-carrier spacing, there is a diagram or line, inclined line. What does it mean? This inclined
So
line, sir.
what it's saying that if you go higher in numerology, you use higher frequency band. If you go lower in numerology, you use lower frequency band. That is what it is indicating. Okay, that is 2 to the power n scaling of subcarrier spacing. With increase in frequency band, you are also going higher in the numerology. That is what it is indicating. Is that okay?
Sir, in the recent auction, Jio has bought only 10 megahertz in 700 megahertz band. So the carrier bandwidth can only be 10 megahertz.
Yes. So, but this is an FDD band. So in downlink they have 10 megahertz. In uplink they have 10 megahertz, right?
Okay. Yes, sir.
So that is sufficient, and they want to use it for coverage. If you know, in 4G they have only 20 megahertz band, right? So here they have got all the 3 bands, and everywhere they have got. So for rural coverage and all, it will be very useful for them to provide coverage. Suppose you are in an area, basement area, you will not get any signal, but at least you can get a Geo 700 megahertz signal. You can make a call and you can make some sort of data call. It may not be very high speed, but connectivity would be there. And that we are actually facing. There are some stops where I go, I have to payment because they are actually using even 4G, they are using on 850 megahertz. So their signal reaches even deep inside, whereas other operator signals are not able to reach. So there is an advantage of using lower spectrum, that you have coverage where nobody else would be having. Important for IoT.
Sir, so when you say carrier bandwidth you take the paired one also, like double it, or is it like?
So I mean, when you say 10 megahertz, it is 10 megahertz in uplink and downlink.
Yeah.
It's actually 20 megahertz. But nomenclature we say 10 only.
Yes. So for example, in 800 band, the block size at which we auction is 1.25 megahertz. So if they don't buy 4 blocks, say they can.
So suppose if they buy 1.25 megahertz, in fact they are getting 1.25 in uplink and 1.25 in downlink. In fact, they are getting 2.5.
Yes, sir. So if they don't buy 2 blocks, if they just buy only 1 block, then carrier bandwidth, even 5 megahertz also they cannot use, no, sir? Am I right?
But I mean, yes, in 5G, minimum channel bandwidth is 5 megahertz. Below 5 megahertz, no system will work.
Okay, got it. Thank you.
Minimum channel bandwidth required in 5G is 5 megahertz as of now. So unless you have a 5 megahertz, you cannot run a 5G system.
Actually, this was 1.25 was due to CDMA. Earlier, CDMA was used to be used in a 800 megahertz band. So that's why this nomenclature is coming 1.25 megahertz.
They are still continuing block size of 1.25. So they would be needing contiguous 5 megahertz to actually use in 5G.
Right, sir.
So they have to buy multiple blocks to make it minimum 5 or 10. And they will be requesting for contiguous. So DOT considers that and does. Okay. Now let us look at this picture very carefully. And this picture I have taken from, there's one very good training company called Empirical. On their website, they have a very nice video on this, numerology and all. So on this particular chart, what I'm trying to explain, on the x-axis, I have frequency. In this axis, I have frequency. On the left side, I have a lower frequency, medium, high, very high, up to, they have shown up to 100 gigahertz. On the y-axis, left side, it is the cell size, small coverage, medium coverage, large coverage. On the right side, they have a latency, very low latency, and medium latency. How they are correlated? Suppose I have 700 megahertz band, that is sub 1 gigahertz, and I want to create a large coverage, this large coverage. So I am using 15 kilohertz subcarrier spacing. Since I am covering a large distance, so your signal will travel a large distance. So there is some time involved in traveling the signal and coming back. So my latency will be medium. It cannot be very strict latency of 1 millisecond or 2 milliseconds. It will be 10 millisecond, 15 millisecond kind of, because I'm covering a larger area. So in case you have a use case where latency is not important, coverage is important, which is for IoT. So I'll be using 15 kilohertz subcarrier spacing, and then latency is not my requirement. Data rate is also not my requirement, so I can use 10 megahertz or 700 megahertz band and create a large coverage, give rural connections and also IoT connections. Technically, it is possible that with 15 kilohertz, I can also have a medium coverage type of BTS. Right? So I'll be covering only less number of distance so that my latency is better. It is possible. But this is not recommended. Why? We'll be wasting certain time resources. We'll be wasting certain resources. Why? Because there is a concept of TP, cyclic prefix, which is nothing but time guard band. Between the symbols, we create some time guard band. So that time guard band is kept slightly larger, so that even in case of a larger coverage, we don't have inter-symbol interference. So if you use for lower side of coverage, your time guard band is more. So you are wasting certain time resources. So it is not advisable. Okay, in case you want to use a smaller coverage, you can use 30 kilohertz of subcarrier spacing, which is allowed. As you have seen, that 30 kilohertz can be used in FR1 in almost all the bandwidth. So there you can use 30 kilohertz. So these are examples. So different use of. Now, suppose you are having a high frequency band, higher frequency band. So as you know, in higher frequency band, your coverage will always be small. Your coverage will always be small. So in that case, I use numerology 2 or 3 or 4, depending upon what band I am using. When I use numerology 2, 3, 4, the city size is less. City size is less. So, and I cover less area, so my latency is better. So I can provide low latency. That means if there is a low latency application, that should be covered with higher frequency band, small size of the coverage, small cell, so that I have lower latency. I hope I tried to explain this concept. If you have any question, I'll try to answer it again. Any question here? Okay, no question, then let me proceed. Okay, the next concept is of carrier aggregation and certain use cases. So in my first section, I had explained that in 5G, more than one carrier component can be aggregated, and that carrier component can be intra-band from the same frequency band A. I have two carrier components that can be aggregated if they are contiguous. If they are not contiguous, then also it can be carrier aggregated. And if I have two different band, interband, and I have one carrier component here, other carrier component here, that this can also be aggregated. In fact, you can aggregate up to 16 carriers. Theoretically, practically, they have gone up to 5 as of now, not beyond that. Okay, so now if you compare with LT supported 5 carrier aggregation. That means they were able to go up to 100 megahertz of the channel bandwidth in a aggregated mode. But in release 13, which was not actually implemented, although that was called LTE Advanced Pro. They supported up to 32 carrier components. That means they could have gone up to 640 mega. So even LTE also advanced to LTE Pro in the later version, 13, etc. But since 5G has now come, so there's no further deployment in large scale of the 4G network. So let us understand the carrier aggregation concept with this picture. This I have taken from 3GPP website. I've given a link. There is a good article on this link. I request all of you to kindly read this. You can copy from the PDF or type in, or if you type carrier aggregation 3GPP on Google, it will come. So what they have explained in this picture that they have lower side of the frequency band. The blue color and the green color is the lower frequency band, and the red color is a higher frequency band. So as blue and green are lower frequency bands, the coverage area would be more, and with higher frequency band, your coverage area would be less. So the concept here is that all the signaling, all the control signaling will happen on this blue one, that is the lower frequency band, so that all the devices, whether the device is here, a device is here, for control signaling, they have the signal they are able to receive, and that's why we call it primary serving cell or primary component carrier. So all those signaling will happen on this. In addition to signaling, data will also be flowing on this. Now on the second carrier, which is also lower side, the data, user data will flow. So this we call it secondary serving cell and our secondary component carrier for user data. The third one, which is higher frequency band, is also secondary serving cell or secondary component carrier, and it is for user data. So suppose a device is here. Suppose a device is here. So it is getting all the three radiations from the three frequency bands. So it's getting the three parallel transmission in uplink and downlink direction. So here carrier aggregation of three carriers can be done. So he'll have so many capacity. And if user is beyond here in this place, so it will at least have two carriers availability, blue one and green. So this is the concept of carrier aggregation in 4G, 5G, in all the different. Okay, so this we have discussed. So I'll skip this. Okay, so if you recall in the morning, we talked about supplementary uplink. So what is supplementary uplink? So suppose there is a carrier aggregation. So you can aggregate certain number of carriers. You can also aggregate a supplementary uplink frequency band, right? And that may be in one of the cell. So in one cell, you have two carrier component and one supplementary in a downlink direction. Okay. Let us look at some use cases of carrier aggregation. Morning somebody was asking, and you please do ask question if you need that. Okay, so look at this picture. Let me explain you. In this picture, what is being shown as an example, that suppose you have a 4G LTE on this tower, you have LTE, and you also have 5G. This tower is having both 5G and LTE. LTE is operating on 2.1 gigahertz frequency band, and 5G is operating on N78, which is 3.5 gigahertz. So definitely, the coverage of 2.1 will be more compared to coverage of 3.5. So here, what you see from here to this is your 4G coverage because it is 2.1, and the blue is your 5G coverage, slightly lesser. And there is a concept of dual connectivity I had explained in my first session, that our device can connect to 4G and 5G both, right? Parallelly, it is possible technically that it can connect to both 4G, 5G. So suppose your device is here, then what it is able to do in uplink and downlink direction, it is able to use 4G, and it is also able to use 5G. So both 4G and 5G. So it has got a double path, 4G and 5G. So dual connectivity with 4G and 5G. If it is in the blue area, that means 4G as well as 5G coverage area. If suppose device is here, so here what we are trying to say is that 5G coverage would be available only for downlink, because since from tower you can transmit more power. So 5G coverage will come here. 4G coverage for uplink and downlink both will be there. And 5G it is only downlink. So this device in downlink direction it has double connectivity. In uplink it is using the 4G connectivity. So this is the concept of carrier aggregation in case of a dual connectivity environment. Any question on this? Please write in chat box.
Yes, sir. Question is that one. If this, you are showing this 4G and 5G are on the same tower. If the 4G and 5G are coming from the different carrier from different tower, will be carrier aggregation will be done?
Yes. So basically, it is a concept of dual connectivity wherein 4G E node B and 5G G node B are connected on XN interface, and they are coordinating with each other. So if that arrangement is made, tower is not a problem. So tower is just an hosting environment. It can be nearby tower or other tower. So yes, it is possible, but that configuration has to be done in the backend. Between 4G and 5G core, certain interfaces are also defined for dual connectivity. And between the two radios, 4G and 5G radio, there is an interface which needs to be connected. If those aspects are done, yes, it can be done. Is that okay, Gulati sir?
Yes, sir. Yes, sir. It's okay, sir.
And there is a question whether this concept is in SA or NSA. So as I had explained in my first session, that it is for both SA and NSA mode. This is possible. Technically, this is possible. How operators are configuring and how whether your device which you have can support dual connectivity will depend. But technically, theoretically, standard perspective answer is yes. Okay, now let's look at this particular example. This is interband carrier aggregation, right? So that means there are two NR carrier 1 and NR carrier 2. That means this is a 5G tower. There is a two parallel transmission. Okay, so here you see that suppose one carrier is 2.1. This is just an example. This can be any other spectrum. For the sake of understanding, I'm telling this spectrum 2.1 gigahertz and say 3.5 gigahertz. Both 5G is operating. So as this 2.1 gigahertz will have a bigger coverage and 2.3 will have slightly lower coverage. So how carrier aggregation will work? So if the UE is in this area, so it is able to do carrier aggregation in downlink direction of both the carriers, and it is also able to do carrier aggregation in uplink direction because both coverage is there. But if the device is here in the greener area, so here in downlink direction, it will get 4G as well as 5G. Sorry, both the 5G carriers. I'm sorry, NR carrier 1 and 2. So in downlink direction, it is using the CA, but in uplink direction, it is only using the 2.1 gigahertz band. So there is no CA in uplink. There is a CA in downlink only. So this is one of the use case that In downlink direction, you are having more bandwidth in certain area. In certain area, you have more bandwidth in both downlink and uplink. So this is another use case. Any question on this? Okay, let's look at.
Sir, hello.
Yeah,
Sir.
please.
Sir, actually, just to explain about this NR carrier 1 and NR carrier 2, that is two UEs are in, one is in blue area and another in green area. But sir, what is the outcome of this? That is how it was, whether this the UE is which is in greener area is beneficial or it's better or the blue one is better. It's not getting clear.
So let us take an example. Suppose you have only 2.1 gigahertz, right?
Right.
So there is certain capacity which system has, right? Certain capacity our system has, and certain data rate our UE can get, right? But if you have two carrier components, so now there are two scenarios. If it is in this area, its capacity has doubled. It is using 2.1 gigahertz as well as it is using 3.5 gigahertz in uplink and downlink both directions. So it is much better than having a single carrier. Here also, in this area also, at least in downlink direction, they are using carrier aggregation. So it is again better than the plain vanilla without carrier aggregation. So that means if my data requirement is more, I should use carrier aggregation. In India, definitely operator will use carrier aggregation because they had got three bands, 700 megahertz, 3.5 gigahertz, 26 gigahertz. So they will definitely make use of this. And these are the advantages which will accrue. Okay. Now let us take one more example. Let us take one more example. This is very interesting. In this example, let us understand that you have a 5G NR, higher frequency. So what you are having is this particular area is your coverage where UE can do downlink and also it can do uplink because it's a good signal. But beyond this particular area, although coverage is there, but in downlink direction it is able to receive this. There is a power limitation in the UE. Its signal is not reaching. Uplink signal is not reaching to the G node B. So because uplink is not reaching, control signaling overall will not be possible, right? Because control signaling flows in both directions. So although you have a coverage in downlink direction, it is unusable. It is unusable. So what to do? So here, what they will do, they will deploy a supplementary uplink channel, which will be the lower band. If you recall the table in the morning which I shown, all the supplementary uplink channels were on the lower side of the frequency band. If you just refer it again, you'll see that it is a lower band. So because uplink is a lower band, now your UE can talk to G node B on this supplementary channel. So you can use even the downlink part of from the other carrier and uplink. So in effect, what you are able to do, you are able to increase the 5G coverage even if you are using the higher frequency band. So this is the use cases which is possible with supplementary uplink. So even if you are using 3.5 gigahertz, if you use a SUL in the lower band, you will have a almost equal coverage as of your 4G, which you have today, in spite of using the higher. May I request that there is some noise, if you can mute your mic. Atul, if you can take care of this. Any question here?
Yes, sir. Sir, with the supplementary, can we say it is a type of FDD? Type of FDD? Normally at higher frequency, it is.
It's not FDD. It will be, I mean, you should not say FDD. The entire thing will be used for uplink, but it is supplementary. You can, I mean, to some portion, partially you can say that, but normally we are calling it as a supplementary uplink, as a separate service only for uplink, which is not. FDD means the same spectrum, like if you have uplink direction, if you have X megahertz, downlink also you have X megahertz. Generally, FDD means that. Here it is not same, it is slightly lower.
Oh, yeah, that is true. But function wise, it is similar, no? That is what.
Yeah, you can consider that, yes.
Yeah, okay, sir.
Good. Okay, so this is same thing explained in a different diagram, so I will skip this. Okay, yesterday we talked about use of unlicensed band. So how carrier aggregation can be used in an unlicensed band environment. This picture is from Qualcomm, one of their papers. So here what they're talking about, suppose you have unlicensed band and you have also licensed band. These two can be aggregated, carrier aggregated, and in device can enjoy more capacity. So this is possible in a NSA environment and also in the SA environment. In an NSA environment, as you know, you have EPC, Evolved Packet Core, that is 4G core, and then you have LT as a radio. And here we have deployed new radio, 5G new radio, in an unlicensed band. Here U is for unlicensed band. So in this case, LT is a master radio. So all those control signaling flows there, and this UV can connect to both here and here, dual connectivity, and do a carrier aggregation kind of in an unlicensed environment. Even in a SA environment, you can have this carrier aggregation, that you have a normal new radio on a licensed spectrum. You have a new radio in unlicensed, and your device can connect to both this and this and have a more capacity. In this case, this particular base station works as a master radio, and all the control signaling flows through this, and data can be flowing directly also. So this is the concept of unlicensed band. So dual connectivity with LTNR or NRNR would be possible.
Sir, do operators radiate in unlicensed band, sir, in India?
In India, I don't think they have started doing this, but in other countries, they are actually using, yes.
But in that case, those people who are using Wi-Fi or RF radios, they would be in deep trouble if they start using.
No. So please note that this will be unlicensed band will be deployed in a indoor environment. Suppose in your home, instead of your Wi-Fi, you choose to deploy a 5G base station on unlicensed band, so that your device is getting NR radio on a licensed spectrum from outside tower, and inside you are also getting the coverage of this. So your device can do a carrier aggregation there. So that is, it will be used where interference is not expected, and there are certain interference mitigation things also in new radio, which I'll talk about when I'll talk about frame structure. So Atul sir have asked whether ACL feature is by default for every customer. So it's very tricky in the sense that, first of all, operators should have SUL spectrum band. Secondly, their base station should support SUL environment. They should follow the standard. Whatever they have bought, they should buy that particular configuration. Your device should also support the particular spectrum band of unlicensed which you are trying to use. Your device should also support carrier aggregation. Then only, if everything is set, then yes, it will be for. So it's not a straight answer. And then some Deepak Bal is saying that whether there will be always a carrier aggregation possible. So for carrier aggregation, there are a lot of prerequisites. Prerequisite is that infrastructure should be enabled for carrier aggregation. Your device should support carrier aggregation on those bands which you have. Your base station should be connected for dual connectivity if signals are coming from here and there. So a lot of complexities are there. So once these are deployed, your devices are capable, then only answer is yes. Okay, let me move. Okay, so this is last part of the morning session, and then I will give you 5 minutes break and we will start our next topic. So last part is bandwidth part. This I had explained in my first. So here I want to again emphasize here that in case of the 4G, generally your device is designed for 20 megahertz channel bandwidth. That means all UV support full carrier band. In 5G, as we know that we can go up to 400 megahertz of the channel bandwidth. And it is possible that UV can support less than carrier bandwidth. Your bandwidth part, WP. So what are the concepts? Concepts are a bandwidth part is subset of contiguous common physical resource. That means it is certain number of RBs, but has to be contiguous. Number one. Second is every bandwidth part. Suppose you have divided your channel bandwidth into 4 bandwidth parts, 1, 2, 3, 4. Technically, you can use different numerology in these bandwidth part. You can use the same, you can use the different. So it's possible to use different numerology within the, and at a time, one UV can have 4 bandwidth parts. So whatever channel bandwidth you have, it has to divide into 4 bandwidth part at one particular time. And then you can have similar concept differently in uplink, and for uplink you can have different, for downlink you can have different. And then additional 4 bandwidth can be configured for up. Suppose if you are using SUL, then there also you can have a 4 bandwidth part. So each carrier component you can have, but at a time only one. Please remember, only one BWP will be active at a time. Only one. So these, please remember these 5 concepts. So let us look at some use cases of bandwidth part. First use case that although you have overall carrier bandwidth of 400 megahertz, but you can design a UV of lesser bandwidth, maybe 5 megahertz. This is very important for IoT devices. Suppose you want to design connectivity for IoT, you did not go for 400 megahertz. You can go to say 5 megahertz. Then whatever electronics you are designing, you may do it for only 700 megahertz band. As I know that IoT coverage I'll get on lower band. So your cost of IoT, your complexity of IoT will be less. Cost and complexity will be less. So this is one of the use cases. Second use case is about the energy consumption. Suppose your device is supporting this much channel bandwidth, right? But when you're just doing browsing, internet browsing, you don't need this much. So a smaller bandwidth part, which is subset of bandwidth 1, bandwidth part 2 is a subset of bandwidth part 1. I can use when I'm just browsing. When there is a video streaming, I can use the bigger bandwidth part, so that I conserve the energy. When unnecessary, I should not consume more energy. The third use case is that in one bandwidth part, I'm using one numerology. In other bandwidth part, I'm using the other numerology. So that is the third use case. Fourth use case is that if you have non-contiguous spectrum, as we had discussed earlier, so that you can form a different bandwidth part, and you can also leave in between, which you don't know today. Tomorrow something can come. And then the next is the forward compatibility. That means you are using certain bandwidth part in the 5G technology. Tomorrow, some other technology comes, you don't define today, and that you can use later on. So forward compatibility concept is also. Look at this picture, very important. That suppose your UE, let me first explain that on this axis it is time, and on this axis you have frequency. So suppose initially you are just browsing internet, you need less frequency band. So out of this, I'm only using this much bandwidth part 1. So bandwidth part 1 is active because I'm just browsing, I'm doing internet. Okay. Suddenly I started downloading certain video, maybe YouTube or Netflix. My bandwidth requirement has increased. So at this point of time, I'll be using bandwidth part 2, which has got more bandwidth. So it is active. When I have done with that and I'm again browsing, then again we switch to bandwidth part 1. So that means I'll conserve energy whenever I'm not actually using. In case of a LT, it was always 20 megahertz channel bandwidth, whereas electronics is always consuming full power. So that is the concept of bandwidth part. And one of the most important aspects in that, if you look at 4G, the control signaling are spread over entire 20 megahertz. The control signaling are spread over entire channel bandwidth. Like this. This is your control region. So whatever channel bandwidth you have, your control signaling are. So you cannot use bandwidth part. Will not be able to receive the signal. Will not be handshake. Suppose I make a bandwidth part in LT, you cannot use because your control signaling are designed to be spread over the entire channel bandwidth. In 5G, for every bandwidth part, the control signaling, we call it corset. Control signaling, right? Control signaling set. So all the control signaling, so that will be confined within a bandwidth part. That means for every bandwidth part, a separate control signaling are transmitted, so that a UV, if they are using this bandwidth part, it is sufficient control signaling is here itself, and that's why it is self-contained. We call it self-contained. So BWP is in itself self-contained because you can do data as well as you have to do the control signaling. So with this finishes